All right, so next up, we're going to start a pretty short discussion on energy. So let's talk about what energy is first. First off, it's not matter, right? Chemistry is the study of matter and its interaction with energy. So we cover both sides of the coin there. Energy is generally defined as the capacity to do work, right? If you've got a lot of energy, then you're ready to do a lot of work. If you don't have a lot of energy, you can't do a lot of work. Similar to matter, energy is neither created nor destroyed. So that's what's known as the law of conservation of energy. And then there's kind of two main ways we think about energy, and that's potential energy and then kinetic energy. So we can think about potential energy as kind of stored energy. So it's energy there, but it's not actually being used right now, but it's stored. It can be used later on. And then kinetic energy as associated with movement, right? So it's some kind of energy that's actually being released because something is in motion. So for example, if we have a ball up here, this ball has a lot of potential energy because it has the potential to roll down the hill, right? And then as it's falling, it's releasing kinetic energy. And then eventually it comes to rest down here. And now it has less potential energy than it did before. And now its kinetic energy is, back down to basically nothing because it's no longer in motion. And so energy is very important in chemistry and in our everyday lives. For example, we'll take a look at our example at our cars yet again. And this would work for electric cars as well. Electric cars also, store potential energy and whatnot. But in terms of our, gasoline powered cars, we take octane, combine it with oxygen to form carbon dioxide and water, plus a whole lot of energy. In this case, the delta H of this reaction is negative 10,920 kilojoules. And so we can see when we go from left to right, we're releasing energy. And the kind of energy that we're releasing here is chemical energy. Which is a form of potential energy. And this potential energy is held within the bonds of the compound, right? So these carbon-hydrogen bonds, they have potential energy. And then when we burn them, we release that energy and form essentially more stable bonds with these carbon-oxygen type of bonds. In terms of our energy, we can have different types of units. For our course, we're going to mostly stick with joules and kilojoules, but there's other types of energy out there. For example, 1.84 kilojoules is equal to 1 calorie. So that's kind of, the food you eat. Right on the back of the wrapper, it tells you how many calories. It's just a unit conversion to get to joules, right? So calories, joules, talking the same thing. I don't like the unit calories because this next part right here, 1 calorie is equal to 1,000 calories. So how does that make any sense? Well, you have to look at the capitalization. This is a capital C and this is a lowercase c. And so they're actually different. I don't know, in my opinion, that's pretty dumb, but it is what it is. Another commonly used form of energy for your home is the kilowatt hour. And so 1 kilowatt hour is equal to 3.60 times 10 to the third kilojoules, right? So a kilowatt hour is a good amount of joules. But you can see, all of these are just different units of energy, but we're talking about the same thing. And again, for our course, we're just going to stick with joules and kilojoules.